Alright, today we're going to be looking at the VCE 2020 Mathematical Methods Exam 1. So the timestamps for all the solutions will be in the description, and also my written solutions are going to be there as well. So let's just get started. So question 1, we're given y equals x squared sine x. We want to find dy dx. This is pretty simple, we just use the product rule, so we can find that y dash is going to be the derivative of x squared times sine x plus x squared times the derivative of sine of x. So you can follow this through any way you like to get 2x sine x plus x squared cosine x. So part B, so we're evaluating f dash of 1, where f of x is this function here. So again, we need to work out what f dash of x is first, and then we need to find f dash of 1. So I'll start off with f dash of x. It's pretty simple, just the chain rule. So we'll take x squared minus x plus 3, derivative of that, equals there, e to the power of x squared minus x plus 3, so we get f dash of x equals 2x minus 1 e to the power of x squared minus x plus 3. So now we substitute in our point x equals 1, so we take f dash of 1 equals, well, it's 2 times 1 minus 1 times e to the power of 1 squared minus 1 plus 3, and then you can work all that out, and you should just get e to the power of 3. Starting off with a couple easy ones here. They'll get harder. So, question 2. Car manufacturer is reviewing performance of its car Model X for any given 6-month service. The probability of Model X needing an oil change is 17 on 20, probability of Model X requiring an air filter change is 3 on 20, and then needing both is 1 on 20. So we're trying to find the probability that any given 6-month service Model X will require an air filter change without an oil change. So you can use any probability rule you like. I'm just going to go with the one I'm using here. So I'll write down just what we know. So this is from the question. The probability of an oil change is 17 on 20. The probability of an air filter change is 3 on 20. And then using the other bit of information, the probability of both, so I'll use this little intersection symbol, so the probability of it needing an oil change and an air filter change is 1 on 20. The important thing here is that we're not assuming that the events are independent, because we haven't been told if they are, so we can't assume anything. We need to just use the information that's given to us. So then you can draw up a table, because I think that makes the most sense. So we'll go O, and then not O, and then A, and then not A. You should be pretty familiar with these, and then you can fill out all the spots here. Oh, I've drawn this a bit badly. But that's fine, so we've got 1 in this corner. Down here, we should have 1 on 20 for O and A. The total for A was 3 on 20, the total for O was 17 on 20. The only important part here is the probability that we need an air filter change without an oil change. So what we're looking for on this diagram is probability of O complement intersection A. And then you can go to your table and you can see that that's this square right here. And so the only thing that works in here will be 2 on 20, because we need to add it together to make 3 on 20, and then we can reduce that down to be just 1 on 10. So your final answer should be 1 on 10. Probably don't need to show that many steps in your working out on the exam, but just so you can follow my thinking, I've written it all out there. Okay, so now we get into the the general form of this question. So this is very similar to the previous one, but this time you're going to be using variables instead of numbers. So I'll just write down the given information quickly. So we start off with probability of an oil change as the first bit of information given is m on m plus n. probability of an air filter change is n on m plus n. The probability of both, so O intersection A, is 1 on m plus n. And then we're trying to find m in terms of n if the probability of model y requiring an air filter change without an oil change is 0.05. So this is another bit of information they've given us. They've given us the probability of it's an air filter change without an oil change is 0.05. So that's important too. So we'll draw up the same table as before. So O, O dash, A dash. There's one down that corner. So here let's fill in all the information. We know this is m on m plus n. Oops, that's not right. That's for the air filter change, so that should be n. Over here we have m on m plus n. And in the intersection, we have 1 on m plus n. And then the other bit of information we've given is this one here is 0.05. So once you write out all the information you know in the beginning, it's really easy to see how this table can come about. So now we want to find m in terms of n. So really we just want to give an equation that has m and n in it. And I'm seeing a really easy one pop up right here, where you can just add these two numbers together and get the other one. So that means we get this equation here. So 1 on m plus n plus 0.05 equals n on m plus n. So now from here you can solve for this any way you like. I'm just going to multiply both sides by m plus n. So that would give us 1 plus 0.05, which is just 1 on 20, times m plus n equals n. So I'll rewrite this one as 1 on 20 because we like to give our answers as fractions. And then this, if we rearrange this, gives us 20 plus m equals negative 19 n. And so we need to get m in terms of n, so all we need to do here is move the 20 to the other side. So m equals 20 minus negative 20 minus 19 n. So there's that question there. So not too bad so far. Okay, so moving on to question 3 here. So we've got a part of this graph with two unknowns, y equals tan ax plus b. We've got 2 points on the graph, and we know it's continuous over the given domain. So we're trying to find the value of a and the value of b. So this should be pretty simple. All we're doing is solving for the function itself. So we're going to start off, so we've got our 2 points here, our -1, and our 1 root 3. So I'll take our first equation. So we're going to solve for our first simultaneous equation, and I'm going to use the point -1, -1. So we're just going to substitute that into our y equals tan ax plus b. So we get -1 equals tan of b minus a. And then you can take the inverse tangent of both sides. So be careful when you do this, but it should be fine here. So we go tan inverse of -1 equals b minus a. And then you can work this out using whatever rule you like. Think about it on the unit circle. The inverse tangent of -1 is negative pi on 4 equals b minus a. That side hasn't changed. And we're going to leave it like this. So this is our first equation, and we're going to use the second point to get a second one, and then solve for b and a. So we've got our second point is 1 root 3. So we're going to put in root 3 equals tan of a plus b. And then do the same thing, take the inverse tangent of both sides. So we get tan inverse of root 3 equals a plus b. And then if you look at our the triangle that we have the 1, 2, root 3 triangle. Tan is opposite over adjacent. So we want the opposite side over the adjacent side to be root 3, which means this would be our angle, because we get root 3 divided by 1. And we know from the triangle that this angle here is going to be pi on 3. So that's a long way of just saying that tan inverse of root 3 is pi on 3. So we get our second equation for A and B. So now what we can do is I'm just going to rearrange this first equation in terms of A. So we get B equals A minus pi on 4. And then we're going to substitute it into equation 2. So that gives us pi on 3 equals 2 times A minus pi on 4. So we're just replacing the B in equation 2 with the B we found here. And then we can bring the pi over 4 to the other side, and we're going to divide by 2. So really this just gives us A equals a half of pi on 4 plus pi on 3. We get to some really gross arithmetic here. So this is 3 plus 4 is 7 on 12, 7 pi on 12 times a half. So A is 7 pi on 24. That's a value for A, so you can put a box around that to show that's one of your answers. And then we're going to find our value for B. I'm going to use equation 2, you can use equation 1 if you want to, it doesn't really matter. So then we get pi on 3. I'm going to bring the A to the other side before I do any of this, so pi on 3 minus A equals B, so 7 pi on 24 goes in here, because that's a value for A, equals B, and then we get some more gross fractions, but you can just expand these. So I'm just going to make the denominator for pi on 3 24 by multiplying by 8, so it gives us 8 pi minus 7 pi all over 24, and then you can see that 8 minus 7 is 1, so we get our answer as B equals pi on 24. So for this one, A is 7 pi on 24 and B is pi on 24. I don't think this question is itself too difficult, but the working is, and you have to be really careful with the pi's and your fractions here, which is a bit of a trend in this exam, and that makes it a bit of a mean one. Yeah, so moving on. Question 4, so this is very algebra based right here, so solve the equation, what it says here. I'm not going to read that one out. So we're going to use our log laws, so you have to be really familiar with your log laws when solving this question. I'll say what they are when I'm using them, so hopefully you can follow along. So first of all, I'm going to bring in this 2 and make it squared, which is just, you can kind of like factor out powers within logs, if you remember that law. So this gives us our new equation, x plus 5, in here everything is squared, minus log 2 of x plus 9 equals 1. So now the logs are all multiplied by 1, there's no like extra 4s out here or anything, which means we can use the other log law, which is you can subtract logs and then you just divide their inner parts. So we get base 2 of x plus 5 all squared divided by x plus 9. So just bringing the x plus 9 down equals 1. So now we've got one log of just one function. So by the definition of a log, which you should all know, you can see that 2 to the power of 1, so this base 2 to the power of this 1 on the right hand side, equals our inner log. So Another way to think about this is you're raising 2 to the power of both sides, and then the log comes down. So you get x plus 5 squared over x plus 9 equals 2, and then multiply the x plus 9 over, get x plus 5 squared equals 2x plus 18. So now we get to just do some fun algebra. So let's go, I'll do this in red over here. So I'll expand out the x plus 5 squared to give us x squared plus 10x plus 25 equals 2x plus 18. We can subtract both the 2x and the 18 from both sides to give us x squared plus 8x plus 7 equals 0. Factorize this, so you can, quadratics. I know they're both going to be positive here. And then you can see from here that only 7 and 1 are going to work, because they add to give 8 and they multiply to give 7. So you get this equals 0. By the null factor law, you get x equals -7 or x equals -1. Now, a lot of people would stop here. You need to be really careful. Make sure that none of these are like extraneous solutions. So you haven't introduced a solution that doesn't make sense. So let's substitute these back into our original equation and see if it works. So x equals -1, we get 2 times log of 4 minus log of 8 equals 1. Okay, well, nothing's gone wrong just yet, and we can trust that that's correct there, but so now we can move on and get x equals -7. So if we put in x equals -7, this log here becomes log base 2 of -2. And that's a problem, because you can't have log of a negative number. It's an undefined answer, which means that the equality is only true for x equals -1, and in doing all our algebraic work, we've introduced another solution that doesn't actually satisfy the original equation. So what you need to write here is you reject the x equals 7, or x equals -7, sorry, and you say, like, since the log is undefined, or whatever you want. But really, the important part is that we're rejecting one of the solutions, and we're only keeping x equals -1. So x equals -1 is our final answer. Oh, that's a bit of a tricky one there. So, question 5. Okay, so for a certain population, the probability of being born with a specific gene is 3/5. And we're seeing the independent, so this is what they're telling us is independent. That's important. We can factor that into how we're going to solve this. So we're looking for a randomly selected group of 4 people. Probability 3 more people have the gene. If you've done probability practice questions, you'll see this is really obviously just a binomial probability question, because we've got a chance for a success. We're looking for a certain number of successes out of like n trials. So it's a binomial question, so we can write big X is a random variable, which is a binomial distribution with n, so the number of trials is going to be 4 people. And the probability of success, I'm going to consider a success as someone having the gene, is 3/5. So this is our n and our p. And so what we're trying to find is the probability that 3 or more people have the gene. And this is shown with our probability x is greater than or equal to 3. Because if they have the gene, if 3 people have the gene, that's x equals 3. If 4 people have the gene, that's x equals 4, out of the group of 4 people. So greater than 3, out of our 4 people, we have to split this into 2 probabilities. So this is the probability that x equals 3 plus the probability that x equals 4, because that's our, we've got 2 cases here where we want, because we want the probability that 3 people have the gene, or the probability that 4 people have the gene, both of those. So now we have to work out each of these separately and then add them together. So there's a lot of moving parts in this question. Just be careful when you're solving it. So I'm just going to write down the formula. This is on your formula sheet. You don't have to write this down when you're actually doing the questions. But we take the binomial formula, which is the probability that x equals little x is our n, x, this is combinations, p to the power of x, 1 minus p to the power of n minus x. So I'm going to just write all this out and then we can work through it. So n is 4. I'm going to do x equals 3 first. So 4, choose 3, times 3 on 5 to the power of 3 times 2 on 5, because that's 1 minus 3 on 5, to the power of 1. Now we're going to add 4, choose 4, so this is our probability x equals 4 now, times 3 on 5 to the power of 4 times 2 on 5 to the power of 0, which is 1. So now we have to work out what this is. So 4 choose 4 is like, that's just 1, because it's how many ways can you choose 4 objects from 4 objects, and obviously there's only one way to do it if you don't care about the order, which is what the combinations formula gives us. So this 4 choose 4, we can not worry about, it's just 1. Now let's work out 4 choose 3 is using the formula 4 factorial on 3 factorial times 4 minus 3 factorial, which is really just like, you can work this out any way you want, but I'm seeing 4 over 4 minus 3 factorial is 1, 4 over 1 equals 4. So this number becomes 4, and we've reduced it to something a bit nicer. So now I'm going to factor out the 3 on 5, which is going to make it look a bit weird, but bear with me. So I'm going to take out 3 on 5 cubed, and we're going to get 4 times 2 on 5 plus the other 3 on 5, because it's to the power of 4 in the other one. I guess I don't need to put brackets around that one. So now we get this. Okay, so you can work all this out, which would give you 4 times 2 is 8, plus 3 is 11. So this will give you 3 on 5 to the power of 3 times 11 on 5 equals 3 to the power of 3 is 27. 5 to the power of 3 is 125 times 11 on 5 equals, this is gross, 297 on 625. So again, another one where they make you do a lot of fractional work. Be really careful when you solve this. Always go back and check your answers, make sure they make sense. Because doing these and making a single mistake is really easy, and it's something you wouldn't really notice in a probability question, whereas you might notice in a calculus question. Okay, so we're on to the more general case. So in a randomly selected group of 4 people, where's the probability that 2 people have the gene, given that at least one of those people has the gene? So first thing you should do is use the formula that we know for this, because they phrased it in x given y, which is, we know a formula for that. So we want the probability that x equals 2, given that x is greater than or equal to 1. So this formula means we need to have, it's the probability that x equals 2 and x greater than or equal to 1 divided by the probability that x is greater than or equal to 1. And here we need to remember that I'll go back to purple. X is a binomial random variable with n equals 4, and p equals 3 on 5. Okay, so the intersection of x equals 2 and x is greater than or equal to 1 is just x equals 2. But just make sure you actually work out that that is the case. So first I'm just going to work out probability x equals 2. So I'm just going to use the formula from before. So we get 4 choose 2 times times 3 on 5 squared times 2 on 5 squared. And here we can see that 4 choose 2 is going to be 4 factorial and 2 factorial times 4 minus 2 factorial. You can work all that out, it's 6. And so this gives us 6 times 3 on 5 squared times 2 on 5 squared. Now I'm just going to leave it like this for now. I'm going to have a look at what the other one looks like, and then we can try and simplify it. So next, we're going to try and work out the bottom of the fraction. So probability x greater than or equal to 1 is the same as probability, the same as 1 minus the probability that x equals 0. Because you can imagine if all the cases where x is not 0, x is bigger than or equal to 1. So this is just an easy trick to make it, like, you don't have to add up all the numbers from 1 to 4 that you get. And most of these, they won't make you add up like more than 2 or 3. So 1 minus 2 on 5 to the power of 4. Here's all that one is. You can use the binomial formula, but I'm just saying that if x is 0, then we're just getting 4 failures. So it's just 4 probability 2 on 5 in a row, which is raised to the power of 4. Okay, so now I'm going to take the two numbers that we got, and I'm going to divide them in the way that we did up here, the way that we want up there. So we get, this is a gross question, so we get 6 times 3 on 5 squared times 2 on 5 squared divided by, what's that? So I'm going to write 1 as the fraction 5 divided by 5 to the power of 4 minus 2 on 5 to the power of 4. And you'll see why in a second. It's just because everything's got like 5 on the bottom. So it's nice to have them all looking the same. And I've done these before, so I can so I know like what the most straightforward route to get to the answer is. Yep, so now we're going to multiply this by 1, or I mean, I'm going to multiply by a fraction, which is 1. It's the same numerator, same denominator. I'm going to choose 5 to the 4, just because if I do this, then it gets rid of, that's 5 squared, and then the 5 to the 4 goes here, so it just gets rid of all the fractions. It's really nice. So we can just multiply by everything by the same number, the top and the bottom. And so then this gives us 6 times 3 squared times 2 squared divided by 5 to the 4 minus 2 to the 4. So it's just all the fractions have gone away. Hopefully you can follow this. So now the bottom is looking really nice. That's what we want. But the top is looking a bit different, but that's fine because you can see that 3 times 2 is 6, obviously. And we're just doing it twice. So if we wrote all this out, you can get 6 times 3 times 3 times 2 times 2, and then you can like collect them to turn each of them into 6 times 6, and then 6 times 6 times 6 is the same as 6 cubed. And then we've got it in the right form. So here, the a equals 6, b equals 5, c equals 2. You don't need to say that though, because it just says express it in that form. And that's why they give you the form, because if you get it looking like this, you know you've done everything right and you haven't made too many mistakes. I mean, it's very difficult to get an answer that looks just like that, having done it wrong. So it should be good. Again, that's a really gross question. It's a lot of like fractional work, and it's doesn't really test your like maths knowledge, I don't think, but that's what they asked in the exam. So yeah. Question 6. So we need to find the domain and the rule for the inverse function of f. Okay, so first, where we can find this is just by flipping around f and x. So I'm just going to say x and f of x get reassigned to f inverse of x and x, just so I know what I'm doing. But pretty much you just write x equals 1 on root 2 times the square root of f inverse of x. So we're just flipping them around. You can do whatever you want here. I'm going to multiply x by root 2, and I'm going to square it. So we get x root 2 squared equals f inverse of x. And this gives us, therefore, f inverse of x equals 2x squared. And we're going to use the fact that the domain of the inverse of f is the same as the range of f. And the range of f is pretty easy to find. You can just see that a half root x is an increasing function, and it's 1 to 1 over the domain 0 to 2. So you can just substitute in each of those points, because it's not like you're not going to double up, you're not going to reach a maximum, then go back down, no minimums either, because it just increases like that. That's probably not the best drawing like that. So obviously the range is just this. Always check for that before you just plug in numbers to find the range. You've got to be sure of what you're actually doing. But if I put in 0, we get 0. If I put in 2, we get 1. So the range is 0 to 1 inclusive, which is also the domain of the inverse function. So the domain is 0 to 1 inclusive. So that's the answer to that one. So now they've graphed it for us. So you could just as easily have pulled it from this graph too, which I didn't really notice. But that's fine. It's good that we worked out like this, just in case they don't actually give you a graph on the exam. So on the axis above, sketch the inverse function over its domain, and then label the endpoints and the points of intersection. All the things you got to do, just like check them off a list. So you don't have to do this, but I always do, just to make sure. Draw in our y equals x line, because that's the line we're like reflecting it over. We go y equals x, and now I'm going to have a go at drawing f inverse of x. So we know that it intersects here, because it intersects along the y equals x line. And then all the points are just kind of flipped. So the point 2, 1, that means we're going to have a point 1, 2. On the inverse function, the point 0, 0, make sure to label the 0, 0 point, even if it's already labeled and they ask you to label the endpoints. If it's a point on that graph that's important, even if it's already labeled, relabel it, because you're just showing that your second graph also passes through that point. Like you might have drawn something like this, but you didn't label this point. They don't really know what to do, so you would need to label the endpoint. Just a good habit to get into, even if that's not on the marking scheme, but it might be. That's the thing. And at this point, you can see is a half. Okay, and now we just have to draw it. So it'll be the same, like reflected across this line. So I'll just draw that part first. Okay, no, it's fine. Oof. Okay, it's not great. But a second go. Okay, that's fine. I'll take it. So there we go. So draw inverse function. That was not too bad, especially because you don't even really need to do the previous part to get it. Okay, here we go. There's a lot of space here. It's a 4-mark question. Get ready for some pain. So part C. We need to find the total area of the two regions bounded by the functions f and the other, yep, okay, and the line x equals 1. So let's just go back quickly. So I'm going to draw in a line here. So we get the line here, x equals 1. Okay, so we got to find this region, and we got to find this region. So let's do them separately, and we can add them together. Okay, now I've got to be really careful with this one. So I'm going to call this first region 1 and the second region 2. So area of 1 is our integral from 0 to a half, because that's our intersection, and f of x is on top. So we take f minus f inverse dx. Okay, so that's the first one. And then, I'm going to write it as it actually is. So that's 1 on root 2 times root x minus 2x squared dx. The second area is from 1/2 to 1 of f inverse minus f dx. So always remember the dx in there. Equals our integral from 1/2 to 1, same as before, of 2x squared minus 1 on root 2 root x dx. Okay, so now let's just do this separately. So start with a1. I just write them at the beginning so we don't get too confused. So hopefully you can follow the steps I'm doing. I will skip a couple steps every time because don't have enough space to show everything. But hopefully it's still clear what's happening. So the 1 on root 2 factor stays. We're raising the power from 1/2 to 3/2. Yes, to 3/2. So we divide it by 3/2, which is 2/3 times x to the power of 3/2 minus, raise it to the power of 3, divide by 2. So 2 and 3, x to the power of 3, and this is from 0 to 1/2. Okay, so substitute in, so the 0 is going to make everything 0, so we can just worry about the half point. This gives us 2 on, I guess, 3 root 2, just because it as one fraction is a lot easier to work with, times 1/2 to the power of 3 on 2, minus 2 on 3 times 1/2 to the power of 3 equals, so you get 2 on 3 root 2 times 1 on 2 root 2. So I've done 2 cubed on the bottom here, which gives us 8. So take the square root, gives us square root of 8, which is the same as 2 times square root of 2. We go minus 2 on 3 times 1 on 8, because just 2 cubed is 8 and 1 cubed is 1, equals 1 on 6, because I'm cancelling out these 2's, and these 2's multiplying to become 2, so it's just 3 times 2 on the bottom, minus 1 on 12. And that's just, I'm multiplying these. This becomes a 4 if this becomes a 1, because we're just dividing by 2, cancelling out that factor of 2. So 1 on 6 minus 1/2, minus a 12, is the same as a 12, which you can work out any way you want, but I'm just seeing it as a 12th is half as big as a 6th. So it's just going to be, it's like a 1 minus a half is still a half. Okay, running out of space here, but that's fine. So area 2, remember we're going to add these at the end, is if we just go back, you can look back at the integral up there, but it turns into 2 on 3 x cubed minus 1 on root 2 times 2 on 3 x to the power of 3 on 2. It's the same as the one above, we just like flipped around the negative signs. But it's different, it's from 1/2 to 1. Okay, so this gives us 2 on 3 minus 2 on 3 root 2. That's just substituting in our point x equals 1, so that one's easy enough. Then we get, gosh, so it's 2 on 3 times 1 on 8, because I'm doing a half cubed in there, minus 2 on 3 root 2 times 1 on 2 root 2 for the same reasons as previously. Okay, so now we're gonna do the same thing we did before. Oops, I've written a 2 where there should be a 3. That should be a 3. So these cancel out, this becomes a 4. And then these are going to cancel out, and these are going to come together to also become a 4. And so what this gives us, I'll go back to purple quickly. So what this gives us is 2 on 3 minus 2 on 3 root 2 minus 12 plus 1 on 6. So I'm just bringing the negative inside. You can work all this out any way you like, but making the denominators all 12 gives us 9 minus 4 root 2 on 12. It's now the final step. You've got to add the two areas together. So a1 plus a2 equals, it's just this plus a 12th. So if we add a 12th to it, then it becomes 10 minus 4 root 2 on 12. There's a factor of 2 we can take out, so we can just go 5 minus 2 root 2 on 6. There we go. So that's a gross question. There's a lot of arithmetic here. Like you can see, once we set up the integral, it was pretty much just like working with fractions. So this is really not a good question, I don't think, where it doesn't actually test like what you know, right? Like it just tests your ability to do fractions good, which is not really what VCE methods should be about, I think. So I don't know, I've got a mixed feelings about this exam. That's fine. So question 7, we've got a function and a point P, part of the graph is there, showing the point P is not on the graph. So easiest way to do this is the point P is 1, 0. We literally just substitute in the point x equals 1, and we show that it's not 0. So 1 squared plus 3 times 1 plus 5, sorry, I'll move this back up, there we go, equals 9. So you can say whatever you want here. You go, so f of 1 not equal to 0, so P is not on F. Cool, starting off easy. So consider a point Q, A, F of A to be a point on the graph of F. Find the slope connecting P and Q. Okay, don't get confused by this one. Literally, straight line slope. We've got our point P. So, oops, don't want to get that wrong. 1, 0, and a point Q, A, F of A. Literally just year 8 gradients. Y2 minus Y1, F of A minus 0, X2 minus X1, A minus 1, equals F of A divided by A minus 1. But remember, we have F of A is its own function. It's I've written it up there, I'll just copy it down. So you need to write out a squared plus 3a plus 5. So that's in terms of a, and remember it's you need to be really careful with that, because f of a is not in terms of a unless you actually write out what the function is. It's in terms of f. So you need to give your answer like this. So now we're finding the slope of the tangent at the point Q. Don't get confused by this one. Remember, the slope of the tangent is just the value of the derivative. So we differentiate to get 2x plus 3, and then we substitute in the point A, f dash of A equals 2a plus 3. It's a 1-mark question. Don't do anything more than that. You wouldn't be expected to do much more than that. Especially, like, don't try and find like a the value of like a line, because that's more of like a 2-mark question. So yeah, use the marking scheme to try and keep yourself like on track. So we're letting the tangent pass through point P, and we want to find the value of A. So what we need to find, okay, so if the tangent to the graph of f at x equals a passes through the point P, then you can think of it's the gradient of the tangent equals the gradient of Q to P. Right? Because like on our graph, if the gradient of the tangent, if this is our graph here, because this is our point Q up here, and this is our point P. So if the tangent here at A passes through P, then that means that the tangent has the same gradient as the line between Q and P. Hopefully that makes sense. If not, draw a couple diagrams or ask a question in the comments. So we can write this as, we can use our answer from the previous question. I'll write them down here. Equals a squared plus 3a plus 5 divided by a minus 1. And f dash of a, as we know from the previous question, is 2a plus 3 equals a squared plus 3a plus 5 on a minus 1. We get some gross algebra stuff. 2a plus 3, multiply the a plus the a minus 1 over. Squared plus 3a plus 5. Expand this out. 2a squared minus 2a plus 3a minus 3 equals a squared plus 3a plus 5. We can start cancelling. So 3a's on both sides, get rid of those. Subtract a squared, subtract 5, make that into a little 8 there. Hopefully that made sense. And then we're left with a squared minus 2a minus 8 equals 0. We can factorize this as a minus 4, a plus 2 equals 0 by the null factor law. A equals 4 or a equals 2. Again, do a check for all the things, make sure that nothing's broken, make sure if you get a equals 1 then you're dividing by 0 and that's bad, but we're not, so it's fine. These are all fine. We have two possible values of a, which kind of makes sense, right? Because like q could be here or it could even be on this side, and it's quadratic, so it could only really be those 2 points. But yeah, so that's that one. Again, annoying algebra, but it's fine. So give the equation, one of the lines passing through the point P that's tangent to the graph of f. If you do the last question, this should be fine. So pick one. I'm going to pick a equals 4. You can choose a equals 2. It doesn't actually make a difference. But I'm going to go a equals, that's 0. A equals 4. We take f dash of 4 equals 11, which you can see just 2a plus 3. 8 plus 3 is 11. Therefore, our gradient is 11. This should be like autopilot really, once you have your a value, because this should be pretty familiar. So y equals 11x plus c, but we know the point 1, 0, so you can substitute that in. 0 equals 11 plus c, c equals negative 11, so therefore y equals 11x minus 11 is an equation of one of the lines passing through P that's tangent to f. There's another one for the other a value, but it only asks for one. Okay, so find the value k, the shortest possible distance between the graph and the function of the two things. So if you think about the shortest possible distance, now you could, like if you wanted to, get the distance formula between the graph and the point P, and then you could use calculus to try and find the minimum, but it's a lot simpler than that. They don't want you to do that. Or like, you could if you wanted to. I actually don't know if that would work. I mean, it probably would with this question, so it might be a bit hard. So the way that I did this is, let's draw out our little graph here. So I think it's like that. Whatever. Here's a tiny point. Point P is over here. So our distance is this annoying line here. It's a hypotenuse of some right angle triangle. It would be the shortest if it was only pointing straight up to this point here. Sorry, because we're translating it horizontally. I'm just saying f of x minus k, so we're only looking at horizontal translations. So it would be the shortest if it was pointing straight up. So if the turning point was right over the point P. So all we got to do is move the graph so that the turning point is right over the point P. Let's figure out where the turning point is to begin with. So the turning point of a quadratic is just x equals negative b onto a equals negative 3 on 2, because a is 1. Okay, cool. So that means this x value is negative 3 on 2, and this x value is 1, because it's p. So we need to shift the graph 3 on 2 units plus 1 to the right, if that makes sense. So shift k equals 3 on 2 plus 1 equals 5 on 2. It's minus k, so we know it's moving to the right. So we literally just k equals 5 on 2. Hopefully that makes sense. This is just my thinking. There are a couple ways to do this, but I think this is the simplest one. So you can see we would have a graph like this, where our turning point would be on the point x equals 1, and we've just shifted the whole graph to the right, so that it's closer to the point P. Because if we went any further, then it would be another diagonal line. Okay, last question. Or yes, I think this is the last question. Check. Yes, it is. I don't know why I thought it wasn't. Okay. Question 8. They've given you part of the graph. It has a minimum at the point Q, and we're finding the coordinates of the point Q. Okay, it's asking you to find a minimum. Very straightforward. So all you got to do, take our function, natural log of x, take the derivative. Hopefully you're familiar with taking derivatives using the product rule. Equal it to 0 to get the minimum. Sorry, I'm running a bit ahead of how I'm talking. And then we take the log of x, bring the 1 over the other side. Therefore, we get x equals e to the power of -1, just from the definition of a log, and f of e to the power of -1 equals e to the -1 times -1, which is just negative 1 on e. I'll write these as 1 on e. So our point is 1 on e, -1 on e. Hopefully that made sense, because we're just finding the minimum. Okay. So this is a show question. Now, when you get these, you might be tempted to take this and then work backwards. Never do that, because then it's like you already know what the answer is before you start. You want to take what you know, which is this, and whatever else you can use, and then from that logically show that you can get this. You can use that to like help guide you a bit, but never write that in your working before you have it, unless you wanted to work backwards from that one. But I wouldn't recommend that. I'd recommend with these questions, just to be safe, you want to start from what you know and then build up to the new thing they want you to figure out. Of course, you can just guess if you if you really don't know what you're doing and you really don't know how to find this. But it is a 1-mark question, so unless your working is 100% clear and you didn't write this at all, it's they're going to see right through it. Yeah, it's very clear with these questions if you don't know what you're doing. So I'm going to first start with if this is something that we know, d dx of x squared natural log of x equals 2x natural log of x plus x. This means that we can, like if we use our just integration knowledge, we can integrate this one to give us, we can just integrate both sides, I guess, is what I'm saying here, to give us this. So x squared log e equals 2x log e plus x dx. And then from here, we can rewrite this right-hand side. Actually, I'll just do it like this. So we can rewrite this right-hand side as 2 times x log e of x dx, and then plus a half x squared. So it's like I'm doing this, where I'm just turning into 2 integrals, which you can totally do. If you didn't know, that's allowed. A half x squared. It's good when you integrate, actually, to try and like throw on a constant at the end. So I'm just going to go plus C1. We've integrated here, so it's like plus C1 plus C2 because we have to add an extra constant, but C1 plus C2 can be its own constant. So I'm just going to write plus C every time, and just keep in mind that if you're actually solving this, the value of C would be changing every time you do this integration. But really just remember that every time you integrate, just throw in a constant. Okay, so from here, this is what we want. We want this. We want the integral of the antiderivative of x log e of x. So what I'm going to do is I'm just going to rewrite in the right-hand side, and then we're just going to move everything over to get this on its own. So I'm seeing x log e of x dx, sorry, integral, equals, it's this thing minus half x squared, and then we need to divide the whole thing by 2. And then again, the c here is just c divided by 2, because we're dividing everything by 2. Yeah, so it is changing value, but it's fine because it's a constant, it can be anything. So now, from here, you can see it's looking really similar to what we want, which is really good, but let's not worry about that yet. Let's just expand this and see what happens. So we get the antiderivative of the natural log of x with respect to x equals x squared natural log of x divided by 2 minus x squared divided by 4 plus c. Let's just make c 0, because it's just an arbitrary constant. So I'm going to put c equals 0. Easy. I mean, not really easy, but making c 0 makes it work. So this is just like this. It's good. I'm not sure if they would like give you just 0 marks for this question if you forgot the c, but always remember to put the c on just to show that you know like what you're doing with these integrals. Okay, so now find the area, the region that's bounded by f, the line x equals a, and the horizontal axis for x in a to b, where b is the x-intercept of f. Okay, so remember, a has a value. So I'm going to go back to here. So we're looking for the region that's bounded by f, and this line, so this is x equals a. X equals a equals 1 on e, as we found before. So don't think that a is just an arbitrary constant. Remember that a has a value. And we want the horizontal axis and the graph. So literally just this bit here. Cool. Okay, so we have that. Let's go back to the question and just keep that in mind. So this means that x is between 1 on e and 1, and the area was below the x-axis, so it was negative. So to get a positive area, you want to put a negative sign out the front here to give us the actual magnitude of the area. So from 1 on e to 1 of x log e of x dx, because that's our function, we can use the fact we had before, this thing here, to give us, it's just negative x squared log e x on 2 minus x squared on 4. There we go. Alright, here we go. So equals negative, you get 0 minus 1 on 4. Yep, so that's substituting in the point 1, because natural log of 1 is 0. And then, 1 squared is just 1. So 0 minus 1 on 4 minus, okay, so we get 1 on e squared times negative 1. Hopefully this is just like simple log stuff for you. Well, not simple, I guess, just like you know it. Then this squared divided by 4. Again, this is just gross arithmetic here, but it's fine. So there's a negative sign at the front, so I'm going to just flip the signs so we get, it should be a quarter. So positive a quarter to begin with, and then I'm going to put plus. And then we get if we make these fractions into just one fraction, so we end up just like bring the 2 up to the top up here and then the 4 up to the top like you can do, you get negative 2 on 4e squared minus 1 on 4e squared. So I flip the negative out the front, so I don't need to do the ones in there because it's just multiplied, equals a quarter minus 3 on 4e squared, which you can do just because they've got the same denominator here. And this equals e squared minus 3 on 4e squared, which you can do just by multiplying both sides by e squared. And you can work that out. Hopefully this part isn't too confusing. I know I kind of like skipped through it, but there's not much space, so I'm trying to like fit into the space in the exam. But yeah, so this should be your final answer here. Okay, nearly done. Find the value of k for which y equals 2x is a tangent to the graph of g, where g is just, it's your graph of f that's translated vertically. So this is a bit of a difficult question. You do have to think about it a bit. So I'll just write down the working and I'll try and talk through it, but hopefully it'll make sense. So we're trying to find the value of k for which y equals 2x is a tangent to the graph of g. That means that if it's a tangent, their gradients are the same and they share a point or more, at least one point where it touches. So first, I'm going to use the gradient. So the gradient is the same. The y equals 2x has a gradient of 2, and that means that our graph of g must also have a gradient of 2. So g dash, the k just goes away because it's a constant. So g dash is natural log of x plus 1, just like we found before for f, equals 2. So this gives us the natural log of x, equals 1. Now this must be true for this to be a tangent of g. So this gives us x equals e, if we solve that. So now what we want to do is shift the graph vertically so that it's a tangent to that. So we can draw out all our things here. So this was our f. So we're going to move g up a bit, and then I'm going to take this here. Okay, so at x equals e, we know that y equals 2x is a tangent. Oh, sorry, the gradient is 2, is what I meant to say. So we get this one. And then we know that at x equals e, so I'll draw this a little bit better. I want to make this as clear as possible. So this one, I'll go a bit slower. So I'll try and, yeah, okay. So let's say that x equals e is a point over here. Okay, these are parallel lines, trust me. Point here, this is x equals e. It's got a gradient of 2, but it's not y equals 2x. It's like y equals 2x minus something. So we need to shift the graph up by a certain amount. So we need to shift the graph up so that these two lines kind of cross here. And the way we can do that is just by shifting it by k units up. So we say that k equals e. So if we say k equals e, then that means that our tangent line here at x equals e with a gradient of 2 is now going to be shifted up by this much. So it's going to overlap with this y equals 2x line. So hopefully that makes sense, but that's the k value that we need so that this y equals 2x line is a tangent to g. Okay, so moving on to the final question, we're finding all the values of k for which g and the inverse of g do not intersect. So, first thing to notice is that g and g inverse intersect along the line y equals x, which means that along the intersection, g dash has to equal 1 if there's only one intercept. Because if we draw out our graphs here, we get here okay, so this is our like standard f here, f and f inverse, or k equals 0. If we raise k to 1, so I'll draw out our y equals x line here. So if k equals 1, then we get a line like this, and then like this reflected. So you can see that here you can imagine they intercept only once, and then for every higher value of k, it would just be like you're shifting them this way, and so they wouldn't touch at all. So this is k greater than 1. So I mean, I've drawn it out like this so you can see that the answer is going to be k equals 1, or sorry, bigger than 1. But we can work this out. So we want to find the intercept line of g dash equals 1, because if the tangent is the same as this like y equals x line, you can see that here they only touch once, they only touches the y equals x line once. That means it's actually a tangent to that graph. So if the tangent is the same as your like reflection axis, then you only get one intercept. Hopefully that makes sense. But so g dash of x equals 1 equals, using our derivative we found before, this gives us x equals 1. Pretty clearly, just to make this part 0. And no other x value works for this. So we get x equals 1. So therefore, g of 1 equals 1, because it's along y equals x, equals 0 plus k. So k equals 1 for only one intersection. So therefore you can see that for k greater than 1, g of x will never intersect the inverse. Or you can also say that g of x is never equal to x. And that is the end of that exam. So that was a very difficult exam, I think, and hopefully you're able to follow everything that's going on. If not, just ask in the comments and I'll try to elaborate.